Hi guys, I'm Jessica. This is the face that I use on the internet, and I tweet at Suttles. You should follow me. I have really great tweets. I want to thank you guys for having me here at Jessica Suttles, LA. That was really nice of you. Before I get started, I want to tell you a little bit about myself and how I became a software engineer. I grew up in Ohio. In case you don't know where that is, it's right here. People in Ohio like to say that they're from the Midwest. I'm not sure that there's a whole lot of accuracy to that. It's pretty far east. But when I was in middle school, I really loved the show Buffy the Vampire Slayer. I don't know if you guys have seen it. I also had a fascination with the web, and so I started to build like fan web pages for Buffy the Vampire Slayer. And that's how I first got into like HTML, CSS, and a little bit of JavaScript. I just mostly edited other people's JavaScript at that point. Then I went to college, and I really wanted to major in fine arts because I thought web design was really awesome. And there wasn't really a web design program at the college I went to. But I did take a computer science class because it filled one of my requirements, and I really liked it. So I just kept doing it alongside of fine arts, and I ended up majoring in computer science. But while I was there, I really only studied like C++ and Scheme, and I was mostly like solving these little like toy problems. I wasn't really building applications or like building anything that I actually wanted to use. But then I finally got a development internship my senior year, and it was this really awesome place called EdgeCase. And then they were New Context, and now they're Neo. You guys might have heard of them. They're pretty popular, mostly in the Ruby community. And they have like really awesome tools for teaching people Ruby, like the Ruby Cones. They also do Git immersion. If you're new to Git, this is a great way to learn it. So while I was there, I just had a great experience of like learning how to build a full application, which was completely different than anything that I had done in school. In school, it had just been pieces, and it was really intimidating to try to build a full application, trying to get like all these different pieces fitting together, even though I had like a full education in computer science. Actually building real-life applications is very different. So I was really excited about building things after I had that internship. So I moved to California. And when I first got here, I went through a recruiter, and I got a job building Ruby on Rails. And I did some iOS apps, and then I did some Android apps. I missed Ruby. I'm mostly a Ruby developer, by the way. I've been doing more and more JavaScript. I missed Ruby, so I got a new job where I was doing more Ruby. And then something really interesting happened. My friend Shane, which some of you might know, he lives here in LA, he really wanted to manage a team of people, and he had never done that before. And he wanted to actually put together the team of people that he wanted to manage and then find somebody to hire all of us. So the team here at the bottom includes a team lead, a brand and UI designer, a front-end developer, and then an iOS and Ruby programmer, which was me at the time. I had experience in iOS and Ruby. And then a JavaScript and Ruby programmer, which we were really close to getting Jason, one of the organizers here, to work with us, which would have been really awesome, but he wanted to do more JavaScript and less Ruby, so he ended up going down a different path. But it was really awesome because it only took 36 days for somebody to decide to hire all of us. And so now we all get to work together. We work here remotely in LA for a company called G5 in Bend, Oregon. So this is what our telecommute looks like. And also, if you know anything about Shane, he runs Farmhouse Conf, which is coming up on May 4th in Hollywood, California, in his backyard, which is a pretty nice backyard. It has a 100-year-old avocado tree, and it's really just a little storytelling series in his backyard. This is a photo from last year. I'm really nervous, so I'm blanking on this name. This is like Obey Giant, Shepherd Fairy. Thank you. But basically, this is the avocado tree you can see behind him, and there's like 100 people sitting in the front just listening to him tell a story for 30 minutes about where he got to where he is in life. And there's about 10 talks, 5 women and 5 men throughout the course of one day. And then at night, there's some entertainment And it gets like really magical at night with like all these lights in the backyard. It's a really fun time, so if you guys aren't doing anything on May 4th, you should totally come. And if you're busy on May 4th, the final Farmhouse Conf 5, will be on November 2nd. And if you want to learn more about this, Farmhouse LA. Another thing that Shane introduced me to is this map, which I think is really awesome. LA is so big, it's huge. You can actually fit like 9 other major cities within the borders of LA. It's like all of these cities fit within the borders of LA. It's ridiculous. And it's amazing that like people manage to come together in LA to create things because it's so hard to get people to come together. So like, did anybody come here from the Cleveland of LA all the way over there on the left? No, nobody came from the Cleveland. The Santa Monica, Venice, Marina del Rey. Oh, you guys did? Awesome, because I need to ride back there tonight. So if you're headed back that way, please come talk to me later. I guess I'll actually start my talk now. So I'm going to talk about the history of women in computing, which is a topic that I've recently learned a lot about just because I was very interested in it. I didn't know much before I started researching for this talk. TLDR, women made programming what it is today, despite many inequities. So let's start way back in the 1800s, before there was even computers. The Jacquard loom was one of the first devices to use punch cards. You can actually see the punch cards hanging down here. And it was meant to simplify the process of like manufacturing very complex textile patterns with like, you know, like Oriental rug kind of patterns. It's controlled by a chain of cards, which were essentially punch cards chained together in like a continuous loop. It didn't actually compute, it just like followed the instructions that were on the cards. Again, the cards there at the bottom. And this idea of the punch cards led to the analytical engine, which was the very first general computer. It was invented by Charles Babbage, and it was actually Turing complete, which means that it could compute anything that was theoretically computable. This was the very first device that was designed that could do this, and actually had integrated internal memory, which was pretty advanced for the time. We're in the 1800s. Ada Lovelace, the daughter of Lord Byron, did a lot of work on the analytical machine, and she was a genius mathematician. She actually described an algorithm for the analytical engine that computed the Bernoulli numbers, which I had to go look up, and I'm still not really sure what they are, but it was complex. And the engine was never completed in her lifetime, so she never got to run her algorithm. But like simulators have been completed since, and her algorithm has been run, and it actually runs. Like there are no bugs in it, which is pretty amazing that she wrote this algorithm that she was never able to test, and it actually worked when it was ran. So she is often cited as the very first computer programmer. So even though she was not writing a program like for a computer, she was one of the first people to write an algorithm that was intended to be ran on a machine. And then we're going to jump way ahead to the 1920s. For some context, this is when the first wave feminists were fighting for voting rights and property rights. Women had no rights to own property at this time, and in the United States, and they also were not allowed to vote. The first wave feminists actually won the right to vote. So in the 1920s, the 19th Amendment was added to the Constitution, which granted women the right to vote. And then on to the 1940s, World War II starts, and it depleted the male labor force. And so the Navy actually started at a segment that was specifically aimed towards women, and there were women accepted for volunteer emergency service, and they advertised towards them. Basically, it was emergency service, which means that women are only accepted because there was no men to fill these roles. There was actually ads like this aimed towards getting women to work. And at this time, computer didn't mean a machine that you ran your code on. It meant a person who performed calculations. And they needed to perform a lot of calculations in World War II for like, what angle to project their missiles at and like how much force they needed to project them. And so a lot of the people hired to do this were women because men were already serving in the army. And yeah, a lot of these women went on to become the first programmers. The first programmers that were employed and paid were actually women, and they programmed the ENIAC computer. And it was a giant computer. It was like the size of a room. And they actually programmed it by like moving these wires around. I think it's interesting that at this time, like women were allowed to handle the programming because that wasn't seen as the important part of computing. The focus was still very much on computer hardware and not the software or not the programming. Programming was thought to be very static and very like low level and clerical. John von Neumann was one of the authors of the very first books published on computing in the United States. And he literally said that coding is a static process, one that could be performed by any low-level clerical worker. And then the other author, once he tried to program, after he had already written this book, actually said, it hadn't occurred to me that there was going to be a difficulty in like writing this program, which is kind of unreal to think about now. You guys have probably heard of Grace Murray Hopper. She's a fairly big figure. She's most well known for coining the term bug. She literally like found a bug in a computer, like a live insect, and that coined the term finding a bug in your program. But she started as a professor at Vassar, and she had a degree in mathematics and physics, and she was part of that WAVES program, so she took a leave of absence to participate in the war effort and contribute her services. She joined the Navy Reserves, and she started out as lieutenant because of her academic achievements and because she finished first in her class during the training period. And after the war, she resigned from teaching at Vassar because she thought what she was doing with the computers was so interesting that she wanted to continue that work. But she was denied entrance into the Navy, and there's different theories behind this. Some people say it was because she was too old, and other people think that it was because she was a woman. But she stayed in the Navy Reserves, and while she was there, she worked on the Mark I computer, and it was a really slow computer. It could perform 3 calculations per second, and so she was really focused on improving that. And she wrote the very first compiler, which is pretty exciting. You guys might not realize it, but like this is the first compiler. And she had a really hard time convincing people that this was a good idea. Because remember how hardware is important right now, not software? People didn't understand the need to do more than add 2 numbers together on a machine. And she did a lot more for programming than coining the term bug. Not only did she write the first compiler, which means that people could stop writing in assembly code, they could actually write at a higher level. She also went on to be the mother of COBOL, which was one of the very first high-level languages. The very first. Before these high-level languages, everyone wrote an assembly language. So to write hello world, you would write all of this. And after she was done with COBOL, you could write this. And that leads to great things today, like Ruby, which you guys don't really care about. This is an ad from the company that Grace Hopper was working for when she was working on COBOL. I can't imagine the kind of obstacles she had to overcome when this is the advertising that the company is putting out, that women are serving their king. And this is an ad by the same company looking for engineers to join their company. I'm not really sure what they're engineering there, but I don't see any women. On to the 1960s. It's time for the space race, which was really exciting, and it also led to a manpower shortage, which caused ads like this to appear. This is actually in Cosmo, and it says that women should join the computing force because it's just like preparing a dinner party. You have to get each piece ready and then make sure they all come out at the same time. During this time also, like, software projects stopped just being data processing, and they started to try to help companies with their management. So today we use a lot of tools that help with project management, like Pivotal Tracker, Assembla, I don't know if any of you guys have used that, or Trello. So people were actually starting to come into companies and be like, okay, what's happening in your company right now? How is this structured, and how can we make software that fits into that or changes it in a way that it makes it more efficient? And this made computer programmers very powerful because they were a part of these discussions with upper management on how their companies ran, and they actually changed how these companies ran because they were writing the software and changing how everybody interacted with each other. And during this time, you start to see the field become more male because all of a sudden programming means power. It's not just about the hardware anymore. During this time, there were lots of women employed. They tended to be employed in very different roles than men. These are women translating programs that are handwritten on paper by men with pen and ink, and they're typing them into punch cards. So it was very hard for women to move up from this punch card role into the people who were programming. So these punch cards were taken from the rooms where the men were writing them into the women's where they would translate them into the punch cards and then taken away to where the machines actually were. And these machines were typically run by men in the basement. And then we see a rise of second wave of feminism, which becomes very prevalent in the 1970s. We see the 50th anniversary of the passage of the 19th Amendment, which allowed women the right to vote. And in second wave feminists, they were fighting for reproductive rights and equality in the workplace. At this time, it was legal for a man to rape his wife, for instance. But the 1973 Supreme Court ruled on Roe versus Wade, and they constitutionalized the right to abortion. And the Equal Rights Amendment passed in both houses of Congress, and this was designed to give women equal rights under all aspects of the law, not just voting rights or not just property rights, but basically just equal rights across the board. And because there was this push for the second wave feminists, it really increased women's interest in having a professional career, and not only having a professional career, but having it in traditionally male-dominated fields. Large numbers of women at this time were entering the STEM fields. And this graph will be reoccurring throughout the presentation. I'll show you more of it as we go on. But basically, this is the percentage of degrees in undergraduate that were earned by women in different fields. So all the way at the top, the black line is all fields. Then we have mathematics, the red line, biological sciences, pink dashed. Then we have the blue dashed line, chemistry. Computer science is the green dashed one. That's the one we really care about. Below that, we have physics and engineering. So during this time, you'll notice that all these lines are trending upwards. And Adele Goldberg was a very important figure during this time. She was a researcher at Xerox PARC, and she participated in the design of Smalltalk 80, which is an object-oriented, dynamically typed, and reflective language, a lot like Ruby. Even Matt says so. But they also developed the concepts behind the GUIs, the very first graphical user interfaces. Before this, everybody used command line interfaces. So this is one of the very first Smalltalk interfaces. You could actually click through these menus, and it would change what you would see. Apple eventually used many of these ideas after they had a tour of Xerox PARC. Lots of things could be said about that, but basically you can see similarities. between the systems. So I mean, how many people here today use a Mac? I do. Might not have been possible without Adele Goldberg. But at this time, like, personal computers were still really expensive. Like, average people didn't have computers, they were just corporate. But it was the golden age of video arcade games, which was how most people like interacted with computers on, you know, a normal daily basis. Not they were doing it every day, but the normal person could. And there were some really great games, like Pong, and Asteroids, and Space Invaders. We'll come back to the idea of video games later. So in the 1980s, a lot of the ground that was gained by the second wave feminists was lost. For instance, the Equal Rights Amendment that had passed in both houses of Congress failed to be ratified by the requisite number of states in time. So that bill was never passed. But women are still doing awesome things. One thing they try to do is disassociate themselves from their name and their title in the professional workplace. So just start to use you know, different acronyms that I have trouble pronouncing, and they start to keep their maiden names. And personal computers now start to experience an explosive growth, especially with the Commodore 64. And women are still entering STEM fields in large numbers. And actually, if you'll notice, the computer science line is like trending upwards more than any of the others. Elizabeth Feinler did some awesome things. She worked at the Stanford Research Institute. She was actually a director, and her group operated the Network Information Center, or NIC, and the ARPANET that eventually evolved into the Defense Data Network and the Internet. While she was a director there, her group defined access to the online directory of people called Whois, which a lot of people still use today. And they became an overall naming authority for the internet. They actually managed the registries for all of the top-level domain names at the time. And remember Adele Goldberg helped define Smalltalk? She actually served as the president of the ACM, which is the largest computing organization. But something happens around this time that doesn't seem to happen in any of the other STEM fields. If you notice, the computer science line starts to trend downwards. And I don't have any definite answers about this. I don't think that anybody does, but there's ideas about it. And one of them is that computer science was a very new field. The first department in the United States wasn't founded until like 1962. Purdue founded the very first computer science department. So it's very new and exciting when we see that upward trend in the graph. And these departments in universities arose out of very different departments. Like whoever was interested in computers at the university would start a program for people to learn more about computers. But as it matured, it tended to find its home in the engineering department, which, if you'll notice on this graph, is the very bottom line, where women aren't very present. It's like maybe that influenced the departure of women from the field. Video games also become much more ingrained in the daily life. You can carry them around in your pocket now. But whereas before, it was like Space Invaders and Asteroids, they start to become gendered now. So before we had Pac-Man, and now we have Mrs. Pac-Man, which I don't think Mr. Pac-Man was very gendered until Miss Pac-Man came along. You also see a reoccurring trend of the male protagonist in video games that is rescuing a female in distress. For example, Donkey Kong or Mario. And I've had some people say to me, I don't think that's very fair that you call that out as deterring women from computing, because these video games are just representing the stories that we're told as children. And I think that's definitely a problem too. That's totally a problem. But I think that video games are more directly connected with computing than the stories that we were told as children. And other people say, well, I played a lot of games where there was strong female protagonists. But they tend to be objectified a little bit. Like, I think this is really advertising towards a man to play this role than a woman. And if you're interested in this topic, I would definitely recommend checking out Tropes versus Women in Video Games. Anita started a Kickstarter for it and got awesome support. She also got really terrible feedback from some misogynists, but you know, she got to make her videos, so that's great. And I think games are important for getting people into computing because I think that that's people's like earliest connections with computers. And if they really love interacting with computers in a gaming sense, like that's a drive towards wanting to learn how that works. And a lot of people I've spoken to, their very first computer programs were their attempts to like make games. During this time, you also start to see the image of the stereotypical nerd appear in male culture, which I don't think this is necessarily male-friendly either, but it's just the fact that it's always portrayed as a man. Like, yes, nerdy is not attractive to anybody, maybe, but this was always portrayed as a man in popular culture. We're getting up to current day. The third wave of feminism rises in the 1990s. Just as a side note, the waves of feminism aren't about like popularity. They're actually about like different ideas, but that's outside the scope of this talk. It's not a pickup line. 1992 is the year of the woman. Tons of women were elected to high office in the United States. It's like women in general are making great advances. All of these women were elected to high office at the time. But women are still leaving computer science, but not the other STEM fields. And so before we saw with second wave feminism that there was an increase, but this didn't happen this time. I'm not entirely sure why this happened. I'm just pointing out that it is a fact. This book is super interesting. If you're interested in figuring out how to invite more women into the community, I would definitely recommend reading it. It's written by Jane Margulie and Alan Fisher. They paired up. Jane Margulie was a social scientist, and she was interested in gender and education. And Alan Fisher actually founded the computer science program at CMU. And they wanted to understand the gender imbalance at their own university. And they interviewed 100 computer science students, both women and men, over a period of 5 years. And they made some changes to the administration standards halfway through, or partway through their study. So they kept high GRE scores, and they added emphasis on leadership qualities, dropped requirement for prior programming experience, but they added catch-up courses to help level out the background differences since they weren't requiring prior programming experience. And the results they saw were dramatic. When they started the study in 1995, 7% of the undergraduate population was women, and when they ended, 42%. Now, this is the number of people enrolling the first year. They also made a huge dent in the number of women that left. So this is the attrition rate, and it went from 40% to almost 90% of women staying in the program for the full 4 years. And I think the most important thing to take from this was that they lowered the entry barrier. And so by taking away the requirement for the prior programming experience and then letting people take courses that actually level them up to other people, they lowered the entry barrier. And I think this is important because I'm sure there's plenty of people in this room who started learning computer programming sometime later in their life. I personally at college know when I was learning, there was always those people in the room who knew the answer to absolutely everything. And I didn't do much programming before I went to college. So like, that was intimidating to have somebody always raise their hand and know the answer before like other people in the class had learned this. But I don't know, I think I made it through computer science because those people didn't seem very interested in completing the homework assignments at the same time. So I was interested in completing those, and so I saw myself as still valuable and still good at it. But I think that this is scary for anyone, and this is a great way to get anyone more interested in computing is to help lower the entry barrier. I think this would help get more men into computing. I think this would help get more minorities in computing. is just making technology more approachable, because it's scary and there's so much to know. And if you've been programming for a long time, you don't know how much you know, but like you know so much. And if you talk to a beginner, like every other word out of your mouth, they won't understand what you're saying. So up to present day, not quite present day, but we're still losing women. There have been some statistics recently that are encouraging, like the Harvard undergraduate computer science department is up to like, I think 42% women or something. But I think that we have a long way to go, even if we are in an uptick, because you'll notice we're almost back to like where it started in the beginning. And if you look around this room today, there aren't very many women here. So I think it's still a problem. Fran Allen was the very first woman to win the Turing Award. It had been around for 40 years, and this is like the Nobel Peace Prize of computing. And she got it for her work in high-performance computing. But Adele Goldberg served as the president of the ACM, and it still took 40 years for them to award their award to a woman. But just 2 years later, Barbara Liskov was also awarded the award for design of programming languages. If any of you do object-oriented programming, you have probably heard of her from the Liskov substitution principle, which is part of the solid design principles of object-oriented design. So now the nows. I think, as technology and applications are becoming more ingrained in our lives, I think that software engineers are, we can have a bigger impact on society, because we're actually writing the software that's powering our society. And we can really shape our future. And I believe that a woman's place is in that revolution. And there's other people who believe this too. So Hacker School, it's a school in Manhattan, and it's free to attend, but it's not free to live in Manhattan. And last year, Etsy, 37 Signals, and Yammer decided to provide grants to women to attend this. And they also made sure that they got the word out to women. And so in spring 2010, they had 140 men apply to the program and 7 women. And then when they offered the grants in summer of 2012, they had 182 men apply and 661 women. So just by making sure that they got the word out and lowering the entry barrier, which in this case meant financially, tons of women applied. And they couldn't accept all of these women. They still applied. I just put on the very first Rails Girls LA. It was at Pivotal Labs a couple weeks ago. It was great. Rails Girls is the program that aims towards making technology more approachable to women. And it turns out when you aim something towards women specifically, a whole bunch of them show up. Women are really excited about building things. They want to program. It's a little scary. This was the very first Rails Girls I went to in SF. I helped tutor these 2 students. And that's mostly what Rails Girls is. It's about a coach being paired up with a couple of students and actually walking through an application. In the span of 1 day, they build a whole application and deploy it to Heroku. Some of these are women who have never programmed at all. So it's a really fun experience for them. This is the one in LA. We had a really awesome turnout. We had about 50 students come, and then we had about 25 coaches. So programs like this are a great way to help get women involved in the community if you're interested. Railsbridge is very similar, and there's also a chapter here in LA. They tend to do a little bit more of a classroom style of everybody all looking at the same screen and learning versus breaking up into small groups. And there's also organizations like Girl Develop It, which they teach a wider range of tools. They don't focus on Rails, but they teach HTML, JavaScript, CSS. And there's not a chapter of this in LA yet, if anybody is interested. Thank you.